Hello, and welcome to the Combinations Day 2 and 3 video. What exactly are we combining? Well, we're bringing our coterminal angles and our 6 trig functions together. So we're going to be doing it kind of all at once, bringing all that material together. So just a reminder about coterminal angles. If you're dealing with degrees, you are going to want to add or subtract 360 degrees, or one full circle. And if you are dealing with radians, you're going to want to add or subtract 2 pi, which again is one full circle. So we will be spending some time turning 2 pi into something with a common denominator with your angle so that you can add or subtract accordingly. Now, keep in mind, you may not always need to find a coterminal angle. So for instance, if we take a look over here at problem 16, we want to find secant of the angle, which is 135 degrees. That's on the unit circle. You don't need to find a coterminal angle for that. We're just going to find a coterminal angle until we find something that is on the unit circle. Once we reach an angle that is on the unit circle, you can stop. So you don't need to find the positive and the negative version. You are just finding one version that is positive, that is on the unit circle, and you're just going to keep working until you can do that. So for instance, if we take a look at number 13, I see, okay, we're finding sine. Remember, sine is your y value on the unit circle. And we're finding it of the angle of 23 pi over 6. Well, I take a look at that, and if I just saw this, I go, okay, that's too big to be on our unit circle. But I could also take a look at the picture right here and see, okay, that's like way too many times around. So we need to go back a circle and see what we get. So since we're dividing by 6 right here, I'm just going to remind you that in this case, 2 pi is going to be the same thing as, 12 pi over 6. So when we're finding our coterminal angle, we're going to take that 23 pi over 6, and we're going to subtract 12 pi over 6. So we're going back one full circle, and that's going to bring us to 11 pi over 6, which is in fact on our unit circle. So when I plug this into the problem, I can say that, hey, sine of 23 pi over 6, well, that's going to be the same thing as sine of 11 pi over 6. So I ask myself, okay, sine of 11 pi over 6, what is the y value at 11 pi over 6? And that is going to be negative 1/2. So when I'm looking for my final answer, I'm going to say that my original problem of sine of 23 pi over 6 is equal to my answer of negative 1/2. So please make sure that you're showing your work as you're going through. That is going to be very important. Let's take a look at number 15. So number 15, we have 21 pi over 4. So just a reminder, in this case, 2 pi is going to be the same as 8 pi over 4. So when we keep working backwards, we can say, okay, 21 pi over 4, we're going to subtract 8 pi over 4 until we find something that's on our unit circle. So when I do 21 pi over 4 minus 8 pi over 4, I get 13 pi over 4, and I'm like, yeah, that's not on my unit circle. So I'm going to subtract another 8 pi over 4, and that's going to give us 5 pi over 4, which is on our unit circle. Okay, so we found what we want. So we can say that cosine of 21 pi over 4 is the same as cosine of 5 pi over 4. So remember, cosine is your x value. So I either remember, because I've memorized my unit circle, or I take a look at my unit circle and I say, oh, my x value of the coordinate of pi over 4 is going to be negative square root of 2 over 2. So when I write my final answer, I'm going to say that cosine of my original angle of 21 pi over 4 is going to be equal to negative square root of 2 over 2. Let's try just 2 more problems. Let's take a look at problem number 17. So for problem 17, I can see that we're now dealing with degrees instead of radians. So when we are working backwards, instead of subtracting 2 pi, we're going to subtract 360. So we'll have 840 minus 360, and that's going to give us 480, which still too big for our unit circle, still too many ways around. So I'm going to subtract another full circle until I get an answer that I recognize. So 480 minus 360, that's 120. That's something that's on our unit circle. That's something I can recognize. So I can say that cosine of 840 is really going to be the same as cosine of 120 because they're coterminal angles. Now that we're here, I'm going to ask, okay, what is the x value, or the x value in the coordinate, at 120 degrees? And that is going to be a negative 1/2. So when I write out my full answer, we'll have cosine of my original angle, 840, is equal to negative 1/2. And there you have it. Let's try one more. Let's do problem number 19. Now we come to problem 19, and I look at this and I go, secant, that's not on my unit circle. That's okay. We can change all of our ratios of sine, cosine, tangent, cosecant, secant, and cotangent into something with a sine or cosine. So that's exactly what we're going to do. But before we do any of that, we've got to change our angle here into something we recognize on the unit circle. So again, we're dividing by 6, which means that 2 pi is going to be the same as 12 pi over 6. So when I do 17 pi over 6 minus, 12 pi over 6, that's going to get us 5 pi over 6. And that is something that I recognize on the unit circle. So when I'm trying to find secant of 5 pi over 6, I look at that and I go, I don't know what that is. I don't know what secant is. Well, secant is 1 over cosine. So this is the same as 1 over cosine of 5 pi over 6. And you know what? I know cosine. That's something that's on my unit circle. That's something that I recognize. So let's see. Cosine of 5 pi over 6 is the negative square root of 3 over 2. So this is going to be 1 over the negative square root of 3 over 2. I didn't have an actual electronic copy of this, so I had to take a picture of it, which is why there's the shadow of my iPad. So we're just going to go directly onto the white background. So from here, if I have 1 over a fraction, it's just going to flip the fraction. So this is going to bring me to the negative 2 over square root of 3. But the problem is that you can't have a square root in a denominator. So we're going to rationalize the denominator and multiply top and bottom by the square root of 3, or whatever's in the denominator. So when we multiply straight across, in our numerator, we're going to have negative 2 times the square root of 3. And in our denominator, square root of 3 times square root of 3 is just 3. And so this is our answer. So when we write this up in our final answer, we can say that secant of our original angle of 17 pi over 6 is equal to negative 2 times the square root of 3 over 3. And there you have it. So I've only done 4 problems on this page. Feel free to try any of the others. They are on the blank notes. I have done all of them in the completed notes if you would like to check your work. Feel free to ask me any questions. We have 8 problems in our Go Formative for tomorrow, and I wish you luck.